Plug an LED directly into a power source and it will destroy itself in milliseconds. But add this tiny, inexpensive component and your circuit will safely run for years. Choosing the right resistor isn't a guessing game. It's simple math. In the next 2 minutes, you will learn how to calculate the perfect resistor value for any LED, every single time, without burning a single component. To find your resistor value, you only need 3 numbers. First, your source voltage, like the 5 volts from an Arduino or 9 volts from a battery. Second, your LED's forward voltage. This is the energy the LED consumes just to light up. Red LEDs usually need around 2 volts, while blue, white, and green LEDs need about 3.2 volts. Third, the safe current for a standard indicator LED, which is almost always 20 milliamps. In our calculations, we write this as 0.02 amps. Now, we apply the golden formula derived from Ohm's law. Resistance equals source voltage minus LED voltage divided by the current. Let's calculate a real-world example. We are powering a red LED from a 5-volt Arduino pin. First, subtract the LED's 2 volts from the 5-volt supply. That leaves us with 3 volts that the resistor needs to absorb. Next, divide those 3 volts by our target current of 0.02 amps. The result is exactly 150 ohms. If you don't have an exact 150 ohm resistor in your kit, don't worry. Simply round up to the next nearest standard value, like 220 ohms. Your LED will shine just as bright, and your circuit remains completely safe. But why does this happen? Unlike a resistor, an LED is a nonlinear diode. Once it reaches its forward voltage turning point, its internal resistance drops to near zero. Without a resistor to limit the current, the circuit enters a state of thermal runaway. The current spikes uncontrollably, generating massive heat instantly, melting the microscopic silicon inside the bulb. Finally, always double-check the power dissipation. Using P equals I squared R, our resistor only consumes 0.06 watts of energy as heat. This means a standard quarter watt or 0.25 W hobby resistor is perfectly safe and won't overheat.